7.1 exponential function growth and decay. So here I want you to tell whether the function shows growth or decay and then graph. So for second period, you guys are supposed to do p of x equals 32 times 1 over 2 to the x. And you're supposed to turn it in on Wednesday at the beginning of class and make sure you do it in the color blue, either with a blue pen or a crayon or a color pencil. For third period, you're supposed to do f of x equals 0.4 times 4 over 3 to the x in the color red. And for fifth period, you're supposed to do g of x equals 1/3 times 2 over 3 to the x in color pink, either a pen, color pencil, crayon, doesn't matter. And for sixth period, do h of x equals 10 times 3 over 2 to the x. Once again, it's due on Wednesday at the beginning of class. So an exponential function is a function with a variable as an exponent. So if we have f of x equals b to the x, b has to be greater than 0, and it cannot be equal to 1. The b is your base, and the x is your exponent. So if we have, for example, the graph f of x equals 2 to the x, that's going to look something like this. Notice that as the values decrease, the graph gets closer and closer to the x-axis, but it never reaches the x-axis because the values of 2 to the x can never be 0. In this case, the x-axis or the or y equals 0 is your horizontal asymptote. So we have two types of exponential functions: exponential growth and exponential decay. So for exponential growth, if we have f of x equals a times b to the x, a has to be greater than 0, and b has to be greater than 1. And it's going to look something like this. So this graph goes up to the right and is an increasing function. The greater the value of b, the steeper the increase. For exponential decay, if we have f of x equals a times b to the x, a is greater than 0, and b has to be greater than 0 and less than 1. So the graph looks something like this. So this graph goes down to the right and is a decreasing function. The smaller the value of b, the steeper the decrease. So we have f of x equals 3 over 2 to the x. b is 3 over 2. So then b is greater than 1. Then it's going to be an exponential growth. It's going to look something like this. So what if we have f of x equals 2 times 4 over 5 to the x? In this case, your a is 2, your b equals 4 over 5, which is less than 1. So then it's going to be an exponential decay. So it's going to look something like this. Okay. So we can model growth or decay by a constant percent, increase or decrease with the following function. A of t equals a times 1 plus or minus r to the t. Your t is going to be your final amount. Your a is going to be your initial amount. And your r is your rate. And is written as a decimal. not as a percentage. So in this formula, 1 plus R is for the growth factor, and 1 minus R is for decay factor. So let's do an example. So, Tony purchased a rare guitar in 2012 for $12,000. Experts estimate that its value will increase by 14% per year. So use a graph to find when the value of the guitar will be $60,000. So as you can see, we're talking about increasement. So in this problem, the guitar is acting as an investment. So we're going to use the factor 1 plus R. Like I said before, 1 plus R is for the growth factor. So we can write our function as f of t equals a times 1 plus r to the t. Our initial value is 12,000. Our rate is 14%, which we can write in decimal form as 0.14. And so if we plug everything in, we get 12,000 times 1 plus 0.14 to the t. If we simplify, we get 12,000 times 1.14 to the t. So now let's graph. Okay, so I'm going to plug in my function. 12,000 times 1.14 to the x. So that's my graph. If you go to trace, you can see your value of x and your value of y. We're trying to find when y equals 60,000. So if we go up, it's about 12. So we're going to say that when x equals 12, x meaning our time. So then y equals 60,000 when x it's about 12. So we can say that the guitar will be worth 60,000 in about 12 years. So but we want to know in what year this is going to happen. So we started in 2012 plus 12 years. So in 2024, the guitar will be worth 60,000. So like I said before, a to the a of t equals a times 1 plus r to the t. Can also be written as a equals p times 1 plus r t. P is just another word for initial amount, and we call it principal. So this formula is your compound interest formula. So what if we want to invest or save money in the bank and they have plans in which the interest is paid more than once a year? For example, if the interest is paid twice a year, so in a year we have 12 months, we divide by 2, so then we're getting paid interest every six months, and this is called compounded semi-annually. So what if we're getting paid interest 4 times a year? There's 12 months in a year, divided by 4. So we're going to get paid interest every 3 months. And it's called compounded quarterly. So in general, when compounded interest is paid n times a year, we say that there are n compounding periods per year. So the formula A equals P times 1 plus R to the T can be adjusted to make it to take into account the number of compounding periods in a year. So if there are n compounding periods per year, then we would, the interest rate would be R over N, and the time would be N times T. With that said, we have a formula which is A equals P times 1 plus R over N times N to the N times T. And this is your formula for N compounding per year. So let's do an example. Find the accumulated value of an investment of $10,000 for 5 years at an interest rate of 5.5%. If the money is A, compounded semi-annually, B, compounded quarterly, or C, compounded monthly.
Mr. Lothmar, what's the rule for the addition of 6 cubes again?
Okay, so let's do A. We know that our principal is $10,000. We know that the rate is 5.5%. If we change it into decimal, then we get 0.055. And the time is 5 years. So then for A equals 10,000 times 1 plus your rate, which is 0.055, divided by n. Since we are talking about compounded semi-annually, then it's going to be when n equals 2, twice a year. So divided by 2 to the 2 times 5. When you plug it in into your calculator, you should get 13,116 with 51 cents. For letter B, we're talking about compounded quarterly. So then our n is going to equal to 4. So A equals 10,000 times 1 plus 0.055 divided by 4 to the 4 times 5. When you plug it in into your calculator, you should get 13,140 with 67 cents. And for C, it was compounded monthly. So then there's 12 months in a year. So n equals 12. So for C, we're going to have that A equals 10,000 times 1 plus 0.055 divided by 12 to the 12 times 5. And when you plug it in into your calculator, you should get 13,157 and 4 cents.
Okay.